Welcome to Study Loop.
This is the answer to Chapter 13, problem number 3 from the Smith Organic Chemistry textbook. And in this problem, we're given 4 molecular formulas, and we are asked what molecular ion would you expect for each of these molecular formulas. Just like Chapter 13, problem number 1, this is a pretty straightforward problem. We just need to multiply the number of atoms in each formula by the weight of each of those atoms and then add that together. And our molecular ion is going to be equal to the molecular weight of the formula. And so the only complication that arises here is actually an A. So remember that chlorine has 2 isotopes that are each fairly abundant. So chlorine and bromine each have this. So chlorine 35 is pretty abundant, and chlorine 37 is also pretty abundant. And so when we have a molecule with a chlorine in it, we actually expect to see 2 peaks in a 3-to-1 ratio. So there's 3 times as much chlorine 35 as there is chlorine 37, but there's still enough chlorine 37 that we expect it to give somewhat of a peak. So for A here, we expect to see peaks at 92 and 94, and we expect that to be in a 3-to-1 ratio, since there's 3 times as much chlorine 35 as there is chlorine 37. So for A, we should expect a peak at 92 and a peak at 94, and they should be in a 3-to-1 ratio. Okay, and so the other 3 here don't have any chlorine or bromine in them, so it really is just a straightforward matter of multiplying number of each atom by the weight of each atom, adding all that together, and then that's going to be our M to Z. So for B, our M to Z is going to equal 62. Okay, so from 3 carbons, 7 hydrogens, and 1 fluorine, all of those weights add up to 62. So for C, again, we just multiply 4 times 12, 11 times 1, and 1 times 14, and add that all together. And the answer that we get there is 73. So we expect the molecular ion peak at 73. And then D is going to be exactly the same. So 4 times 12, 4 times 1, and 2 times 14. Add it all together gives us a molecular peak of 80. So the molecular ion peak of 80. And so that's the way to solve this problem. We do just need to remember that chlorine is going to give 2 peaks in a 3-to-1 ratio. And then other than that, it's a very straightforward matter of multiplying the number of atoms in each formula by the weight of each atom and then adding that all together. And that's the answer to Chapter 13, problem number 3.